So, yeah, Pat's got a good question. They're not exactly lined up, so we have to pull the...
Like for the whole thing.
I bet I can finagle it, though. Hang
I
on.
hope so, but you can.
I can just pull the graph over.
Otherwise, that's.
I do this. That's a little better, huh? Ish. And if I stretch it out... How's that? Is that better? That's almost lined up now.
That's pretty close.
Okay, so you got your 5-number summaries up here and your box plots at the bottom. This is gorgeous. Notice they're all different. Why?
Randomized.
You guys drew 20 discrete values. Of course, some of your values were the same as your neighbors, but they weren't all the same. So we actually get 20 different box plots. Even though sometimes the ranges are almost the same, the middles change. Or if the middles are almost, we get any ones where the middles are almost the same? Ish, probably somewhere in here, like these two. The extremes aren't the same. So good, we got 20, or we got 15, I should say, 15 distinct data sets. Yay. So that's how they're different. How are they the same for the most part?
They all tend to be around 30
Mm.
for their median.
If you look at where the medians kind of line up, if you can kind of draw, now we have some variation around this, yes?
Yeah.
If you kind of draw a line like right across here, you've got like a commonality in median. There are some extremes that go up and down, but that's to be expected. In Math 244, there's a thing called confidence. Some of you may have heard this before, the idea of a set level of confidence. If you replicate an experiment over and over and over and over again, and you do it correctly each time, you should capture whatever you're trying to capture most of the time. And that's what the confidence is. It doesn't promise that you always will. It guarantees that you mostly will. So sometimes you're going to miss. So sometimes you're going to fall low or high. So I would expect this kind of hopping up and down, much in the same way I would expect if I took a die and rolled it a number of times, eventually I'm going to see 5 5s in a row. Because it's going to happen. It has to happen because of the nature of probability. So that's how they're the same and also how they're different. And this is absolutely gorgeous. So you get this idea. Where is the most variation on average across the data set? So which of the quarters of the data? So you have the upper quarter. I'm sorry these are vertical and not horizontal. They fit on the screen better if I run them vertically. I tried to make them horizontal, but then the damn thing goes too low because you have too many data sets. So I put them vertically instead. So this is the upper 25% of the data, the highest 25, the next highest, and the next highest here. Which one tends to show the most variation?
The upper.
Vote for the upper, second for the upper, Dave for the upper. Yeah, we're saying upper. Haley, fourth.
Yeah.
All in favor of upper? It looks like that's where most of the randomness is in the upper 25%. This is what makes me nervous about using the average. Because where does the average head? Toward those upper ones. Now, if there were lower ones, if these guys were on average the lowest, then I'd still not want to use the average because it would be pulling it down towards that. But that's not what happens with the snowfall. The snowfall tends to be extreme. Now, part of that is due to the fact that we start measuring at what number? 0. Technically speaking, we have a limit of how low we can go, but there technically is not a limit on how high we could go. We could go as high as we want. Theoretically, I mean realistically no, but theoretically yes. I mean Mount Bachelor got how many hundreds of inches of snow last year? Or the Cascades I should say got how many hundreds? I think it was 500 inches when you actually add it all up what they got. It's staggering when you think about yards. They measure it in yards after a while because the numbers just hit too many zeros on the end of them. So there really is no upper limit on how much you can get. Cool? Cool so far? Good. Now, so we get a very good idea. I didn't have the average indicated on these box plots. Maybe I should add that next time. Have a little shape that shows the average too. Go back and think about that. But forget that right now. Let's worry about the typical data. Carly, concern, go ahead.
Well, I was just gonna say that if you did set yourself a limit,
Yes.
upper and lower,
Sure.
then the average wouldn't really pull towards the top.
If you set a limit, you'd also have to set the distribution of the remaining values, I think. Because if you set a limit, what would your limit be? Give me a number.
I don't know.
100?
Maybe like between 20 and 60.
Oh
If
God.
You're looking at.
But then you're precluding certain data values. If you've set it from 20 to 60, then you can't have 90 inches of snow, but that's happened in the past.
But I just was wondering how you would take out that limit of 0.
Thank you. May I change the data set momentarily to answer that question? You bring up a good point, and actually this happened about a week and a half ago at my house. Let me get into 244's data set. How many of you guys use Ben Broadband for data plan, monthly data plan? Some of you, a couple of you? Okay, we do too. Let me find it. Hang on, where did I put it? I think I put it here. No. Maybe it is in your folder. Plus, no. Where the hell did I put it? Did I put it here? Yep, there it is. Okay. So, here's our data usage, rural family household, from January 2012 to the present. Okay, and the reason I started graphing this was because my wife flipped in January this year when we got the overage bill from Ben Broadband. She's like, what the hell? I was like, babe, what's up? Well, what the hell? We went over our allotted, you get like, I think 125 gigs of transfer, and then if you go over that, they charge you an overage fee.
Yes.
My first question is, do they give us money back when we don't use it?
No.
The answer is no. I'm like, well, duh. But anyway, never mind, I can't change the system right now. So the question is, what do we do about that value? Does that value show a trend upward in data usage that we should then bump our plan up to the next plan? Or is that a random fluctuation point that will not happen very often? The answer to that question is I don't know at this point. Based on the past performance, what you're talking about is something called a control chart, Carly. So what you do is you look at these random little fluctuations over a series of time, and you slap control bars on them, and you say 95% of the time you're in these control bars. And then this becomes a ceiling popper or a basement popper, depending on which direction you go. Then you analyze, does that indicate a paradigm shift, which means we are now going to start trending upward, or was that just the fact that it was 2 degrees and my son was taking the freaking iPad when we went to go skiing at Bachelor and we didn't know he was playing Team Zumi with some kid in Turkey. Thereby pulling data from the satellites the entire hour-and-a-half ride out to Bachelor and back every other day, which is what was actually happening. Now he takes the iPod, which has no data capability. And now we're fine. Now he just pulls the Netflix stuff we've downloaded and everything's fine. So, the answer to your question is there's more than one answer potentially. It might show a phase shift, in which case you don't want to ignore the high values, or it might just be a random fluctuation in the system like this one. Is that a fair answer?
Well, but in something like the case of inches of snowfall,
Let's go back to it.
you can't have like a basement. You can't have one that goes down below because you're never going to have negative inches of snowfall.
Absolutely, but don't ignore, I see what you're saying, but don't ignore the distribution of values just to set a basement and a ceiling. Look at what's happening in between. Look at the rest of the box plots. There seems to be a clustering at the low end versus the high end. I see what you're saying, but don't, I guess the best phrase is don't lose the forest for the trees.
Well, I mean, I guess I'm just wondering, is there a way
to set the limits?
yeah, so that you don't have that.
These things called control charts. And if you take it 244, which you are, right? I'll talk you into it. If you take it 244, we'll hint at that idea of how you set them up properly. It's based on the idea of standard deviations, but you have to finagle the data differently because of what you're trying to set up. I hate to push the question back, but yes, the answer is yes, there is a way. But a lot of times, the problem with statistics, and this can be a problem, is you can't lose the context for want of a calculation. So yeah, I can set a value anywhere I want on that, but it doesn't mean I should set a value, and it definitely doesn't mean I should report on that value. You guys may have heard that the autism rate has jumped in this country over the past 5 years. What very often is not indicated is the autism rate has jumped because they classified more conditions as autism now, number one, and number two, the treatments and the identification of them is getting better. It doesn't mean the autism rate has jumped, it just means we're getting better at actually seeing it. But when you see autism rate jumping, the first thing that I hear when I mention it to people is, oh my God, don't get your kids inoculated. They somehow go from orange and it becomes purple via something. So that's where you gotta be careful about setting ceilings and interpreting them correctly. Is that
Yeah.
fairish? I love what you're saying, and it's correct. Just, it's a little too deep to get into at this point in time.
Okay.
But hold that thought if you will. Good? Yes, the quick answer is yes. I'm sorry, I tend to give the long answer first and then come back with yes. But yeah. Good. Couple things I want to talk about now to set the stage for Tuesday. Each of these box plots has a middle 50%, yes? Those things are called the interquartile range. The distance between the high and the low is called the interquartile range, often called the IQR, interquartile range, sometimes called the IQR. It's not crucially important to memorize that right now, although we are going to use it momentarily, at least I am. I'm going to try to read which of your data points have outliers. Somebody over here, Claire, I think it was, mentioned the word outlier. I mentioned the word extreme value, and she said, is it okay to call those outliers? And I said, hell yes it is, yes. The question is, what makes an outlier an outlier? At what point does a value get too big to not just be big, but too big? So here's what I'm going to do. I'm going to try to predict which one of your data sets have outliers. I need you to set up your TIs for me, though, to check. Go to your TIs. Do you guys all have your box plots turned on?
Yeah.
Okay. Change the box plot to the other kind. So when you go to your second y equals screen, I'll put it up here. When you go to your second y equals screen,
Yeah, you have to arrow, you can't arrow down.
right. So you go to your box plot screen that you have your setup on, and you're set up on this guy. Set them up on this guy and regraph it. Then we're going to answer your question now, finally. I apologize for waiting so long. Now the only thing that changes there is you get this thing called a mark at the bottom. You can leave that exactly as it is. It's probably set on this, I would imagine. It's probably set on that. Totally fine. That's the most obvious one. Then just press graph. Don't tell me what it looks like, though. I want to try to make some predictions based on what I see on the board. Because Excel does not show me that. Some of you guys now have a box plot that has a little mark on it, yes? And some of you don't.
Yeah.
My prediction, Group 1 does not have that mark, Group 2 does. Group 3 does not, Group 4 does not, Group 5 does not, Group 6, I don't think so. Group 7 definitely does. Group 8 probably has at least one. Group 9 does not. Group 10 does, at least one. Group 11 does not. Group 12, yes. Group 13, no, no, and no. How did I do? Or was that too fast? It was okay?
You were wrong for us.
I was wrong for you guys. Good, let's go back to yours again. How was I right in all but one case? What was I looking at?
The skewed.
The skewed, now hang on now. This one right here has got a pretty long whisker, doesn't it? But that doesn't have an outlier.
Because the middle box is big.
Boom! I'm looking at two things at once. I'm looking at the size of that box and also the length of the whisker. Now here's an introduction to the calculation. What I was trying to do in my head, and obviously I did it right except for one. I took the size of the box, multiplied it by 50% and made it bigger. And then I stacked the box on Q3 and Q1. If any data point lies outside of that range, that's considered an outlier. This is one definition of an outlier. So group 2, I went that, 50%, stack. See how he's not past it? He's not an outlier. He's big, but not too big. Okay? Clearly, we're not going to have any here, right? How about these guys? 2 looks like it would, and this is why I was probably wrong with the 1. It was close and I missed it. If I do that and increase it by 50% and then stack, that's getting close. It could be and it could not be.
Increase it by
50%, not just the box, but the box plus 50%. We'll talk about why that is on Tuesday, I promise.
Okay.
That's why this one doesn't have an outlier, although that whisker is super long. When I increase that by 50%, I'd have to be up here somewhere. So that's why this one's fairly clear that it does have at least one. Tiny little box, increased by 50, at least that one, if not more. Anybody have 2 outliers in their data set? You guys had 2. Which group was yours?
We're in that little box, group 7.
Group 7, the one I just did. Yeah. So what that does is I can tell there's at least 1 outlier. I don't know how many there are. Which one were you, Marty? Which group was you guys?
Group 8.
Group 8. Oh. Yep, it was one of those ones that was too close to call. I called it the wrong way. Yeah, but that's the idea. We can do the calculation. We'll do it on Tuesday. But that's a rough ballpark of how the calculation is done. So we're getting close to actually identifying when something is unusual, when something is unusual. As it turns out, just for reference, here's all the snowfall data. There's an average of all, a box plot of all years from 1927 up to 2012. So you see, there was an outlier year. I think it was back in 73. That year where it spiked up to 91, that was definitely an outlier. What was the other spike year?
92.
92, and that was how much snow? 80, that's close to an outlier, it might not be. The reason I bring this up, and this is as you're packing up, just think about this. Recently, a bunch of my friends have been lamenting our crappy state of winter, although it seems to be changing right now. And they go, oh, it's not like it used to be. You heard this, right?
Yeah.
Snow winter used to be so much better here. So much better. Sucks now, sucks now. I said, well, what do you mean it sucks now? We used to get so much more snow, so much more snow. And I'm like, really? Because that's 100 years worth of data. That's 100 years worth of data. That's average snow depth. Average snow depth for every day of the year from January 1st to December 31st up to 2005. And they're like, no, you go down go down McMinimans. Walk in that front door and there's a picture of the nuns like shoveling out 12 feet of snow, right? Oh, we used to get 10 feet of snow all the time. Really? You sure it doesn't average 2 inches? What they're remembering, of course, is the
Big years.
outliers, the big years, and they're forgetting all the years where we had nothing. Dave, yeah? That's what I said.
Well, I was just, yeah, there's.
Thumbs up, exactly. It's hard for us to remember this when we remember the big years. That's why it's important to look at the entire data sets. Friends, have a good weekend. Stay safe, play in the snow if you enjoy playing in the snow, otherwise just drink hot chocolate. If you've got the quiz, make sure all your names are on them. Let's get you 10 points.
Just one per pair.
You can do one per pair, make sure both names are on them. Chelsea, appreciate that. Oh, no. Oh, look at those freaking things. Those are like grimace hands. Oh, my God. Oh, my Yeah, don't you worry about it. This right here, all is well. My friend? Turn off the camera. Pat, do you mind just turning the camera off? Thanks, man. Or just closing the screen. That works too.